Alright guys, this is our agenda today. We're going to solve the fish bus problem. Oh, this one, dear. Alright, this one. Nope. Okay, so get it from here. Alright. Alright, oh, oops. Alright, so what is our input here? Yeah, integer number, right? So that's an input. So let's focus on the first part 1, and we'll come to the next one. So output, yeah, yeah. So basically, right, print, right? So basically, this one O bus, right, and O fish bus, right? O not fish O bus. Okay. So this one. Okay. So so let's do some understanding. So basically, we need to use. We are checking the divisibility, right? So how do we check divisibility in programming? Modulo operator. So let's do some understanding. Okay. So you can use main program for that. So I'm going to create that number, right? So this guy. So let's say this is 6, right? So you can print out few things, right? Test out the modulo operation, right? So by modulo by 3, right? And this will print 0, right? Okay. So that means basically it's evenly divisible, right? So this means this is this, right? Okay. So let me take that number to be like 10, right? So if this is 10, and we know that this is not evenly divisible by 3, but it's actually evenly divisible by 5, right? Okay, and we'll see that we'll get 1 in here, right, because the remainder is 1, and then in here it's 0 because it's evenly divisible, right? So this is actually this one. Okay, so if if the number is let's say 15, right, and you can see that both is divisible by both numbers 3 and 5. So this is a fish bus situation, right? And then of course if we get a number, another number, right, so we will not get it. Like for example, a number like let's say 16, all right. So this is not FIS or bus situation, right? So not FIS or bus. Okay. All right. So that means basically we can use if else statements and then figure this out, right? Okay. So okay, and you can see that in our problem statement we also see that vocabulary, right? The vocabulary if it's in there, right? If this is this and such and such. So what's a good match for this one then? I'd say um, um, the grade calculation one, the letter grade one is a good match. Okay, and also in regards to the modulo, we have a bunch of, right? So those are also matches, right? So modulo problems. So problems involved in modulos, okay, and basically letter grade one. All right. So let's write a plan. Okay. So now here, and you can see that um, if I use like if I use if I only check for let's say for divisibility by 3 first, what can happen? Or in other words, what check should I do first here? For example, if I only check for divisibility by 3 but the number is 15, I might incorrectly return FIS, right? Because 15 is divisible by 3. So if I start my if statement with that, I'm going to get it wrong, right? So what should be the first check then?
Create a boolean that is set equal to true if the number is divisible by 3 that you can then use later to check for both cases.
It's in fact the other way, right? So my argument is if I only check first this one, right? And if the number is 15, I will still return this, right? So then what should be the first check? For both, right? That should be the first check. Otherwise, for 15, I'm going to get it wrong, right? So first check should be, we're going to first check the divisibility by both 3 and 5. And then once we verify that, then the rest can come, right? So basically, so let's write our algorithm, right? So we're going to first input, step 1, input this number. Okay, it's 2, right? So now if, right, if is divisible by both 3 and 5, right? So we're gonna basically 2.1 print. Oh, I think we should return. Sorry, return FIS, right? Okay. Oh, sorry, FIS bus. Sorry, yeah, FIS bus. Thanks. All right, and then else, right? So basically, step 3, right? So I can copy paste and I'm going to change. Okay. So else if, right, is divisible by 3, right, and we're going to return FIS. Okay, so 3.1, and next one. So step 4, else if by 5, so we're going to return bus. Okay, and the scenario, basically last one is else scenario, and step 5, else basically 5.1, return basically not fish or bus, right? Not or bus. Okay. This is the interview question, guys. We're gonna see why it's actually interview question later. Okay. All right. So let's now. Okay. So this is our algorithm, and then I think I highlighted the importance of this step to the previous class also, guys. Okay. Especially in this AI era. All right. Interviewers looking for this step even more now. Okay. Because you know AI can code now, right? So if you can give you the correct algorithm, AI can code even better now. So they are actually now basically looking for this from the student even more than they were looking for earlier. So they basically usually in an interview, interviewer looking for the design of the solution from the student first. So for example, if the student didn't care about this, just solve the code like in the whiteboard, that student going to likely be failed by the interviewer, right? Even though it's a perfect solution, because there was no architecturing part, right? There was no design part of the solution. So that's where the thinking happening, right? Because we are thinking in English, right? So um, make sure to come up with this, and make sure it is not vague, right? Because then it's a translation problem, right? If it is vague, we're going to struggle in translation, right? So make sure your algorithm or the plan is correct and complete and in detail, so that you can actually step by step translate. And then we actually saw a couple of time, right? And uh, I actually wrote over here the incorrect algorithm, and translation also went in incorrectly as well, right? So it's okay to make a mistake, and because Ampere process encourage you to go back and forth anytime and make correction, right? But try to make sure your English solution, the algorithm is correct. Okay. All right. So let's translate this. So I'm gonna write our function def. Let's say solve fish bus, right? um, so there's a number, right? Integer number input, problem for the number. Okay. So fish hyphen. Okay. All right. so if the integer is divisible by both 3 and 5, so if right modulo 3 equals 0, that's the right, and modulo 5 equals 0, what do we do now? Return, right? So return FIS bus. Okay. Tuesday we learn a technique to make it a little bit elegant. What can we do over here? You can get rid of the equality, right?
Oh, yeah.
Using the truth value of 0, right? So then basically we're going to put not over here, and then I can remove this, and here also not, and I can remove this. Okay. Oops. Okay. All right. All right, so I'm gonna copy paste, guys. Okay, so the next one is the disability check by 3. So just this one, and we return FIS, and the next one is this one, right? Oh, I think we need not, and we return buzz, right? This should be, all of these should be elif, right? All right, and then last one else, return not FIS or bus. Okay. Okay. All right, so let's run this. So I'm gonna print a call, right? So let's say like it actually, we ask I asked 15, 12, 25 and 31, right? So the first one is 15. Yeah, we got FIS bus, right? Correctly. Next one is 12, 25 and 31. So 12 and 35, 25 and then 31. Okay. All right, so it's working, right? So let's see the scope for the improvements, right? Oh, okay. So before that, we need to actually do it in a while loop, right? So write another function to run your function above using a randomly picked integer number from a given range until the number. So why this is a while loop? So this part, the second function,
Until.
yeah, the word until, right? So basically, so the word until is there, so it's indicate it's a while loop problem. So basically, we are given, so there are inputs to this one, right? What are the inputs to this function? Yeah, the start and end, the range, right? That's the range. So and then basically we randomly pick the number in there, and then we're gonna run it for that number until the middle of that range become that number become that. Okay, so let's write the plan for that. Okay, so this is plan 2. Okay, the input to that function, input start and end, let's say end. All right, then we have to calculate the midpoint, right? So calculate midpoint. What is the midpoint? How do we calculate the midpoint between two numbers? Mm-hmm. I think you're right. Oh, isn't it start plus n minus start divided by 2? That is that the one?
Start plus n minus start divided by 2.
Yep. Start plus n minus start divided by 2.
Would that just be the same thing with n divided by 2? Because you're doing start minus start.
Let's see. So yeah, I think it's basically start plus end divided by 2, right? Start plus end. Yeah, yeah, you're right. So because when you add the mathematics, right? So yeah, half of start minus start by sorry start by 2 goes away, right? Yeah. So basically end sorry start and plus end. But we'll have to use what kind of division here? And it actually worked. So because remember we're gonna create a random integer, right? So this probably should be a integer number, right? So I'll use actually integer division. Okay. All right. Otherwise you will random floating point number can may not be comparable to the midpoint because it's a fraction, right? Yeah. So we have to make sure that otherwise there's a chance that the loop may run forever because that comparison may not materializing. Okay. So now what do we need to do? 3 step 3, we'll have to first generate this random number, right? So generate random this guy integer number between start and end. So we basically going to use random.randint, right? We can also use randrange as well. So for now it's a while loop. Okay. So while, what should be the condition? Yeah. While not, right? Not this guy. I would say like this as well is fine. Not equal, right? While I would say not what that's fine. While is not equal to, right, to the midpoint. This is in English, right? What do we do? 4.1. What's the next step? What do we do in while loop? What do you do in while loop?
You check the first function that
Yeah, so run solve is bus for, right? Run solve is bus for what?
the random number that we generated.
Yeah, for random this one, right? All right. Is this all or we need something else? There's one more line or not? In the current form,
Well, it's not nothing being printed.
yeah, so basically this the now we are using our function we wrote first, right? But this is still wrong.
There's no print statement of the first function, so this is just this is just running it a bunch of times but not showing us the outcome.
Well, imagine, yeah, so I did that. Okay, so basically print a call to like this, right? Okay, print a call to, right? still wrong. What's wrong with it?
Oh, we're not iterating we're not changing the number.
Yeah, we have to change. We have to check again, right? So we change means we have to generate this again, right? So otherwise, um, it can be a infinite loop, right? So 4.2, right? So generate this number again, or reassign, right? Again, all right. So this is correct now, okay? All right. Otherwise, this could be either no or just infinite loop, because we are not updating the loop variable, right? See, the loop variable is random number, random integer, right? All right. So let's convert this to code. So I would say run. Let me see what I got from the other class. Forgot. Yeah. Yep. Okay. So run solve is bus in loop. All right. It has two input, start and end. Okay. Runs in a loop. Okay. We can write a more versatile one. Okay. All right. So step 2, basically we now need to calculate midpoint. So midpoint is this, and then the this one, right? So we need to import the random module, right? And then usually we import at the very top. Okay, that's the standard. All right. So this number so random integer number equals random dot rand int. Okay, and the start and end, right? So okay, now while loop part, while, right? um, so this one not equals, right, midpoint, right? Okay, so basically what we print a call to our function, this one, and right, what are we passing? The random integer. Okay, and then in the end we reassign a new random number, otherwise this is going to be an infinite loop. Okay, or no, at all, not at all, right? So sometimes if this guy, so basically this loop will not go inside if this already equal to midpoint, right? There's that chance, right? Okay, all right, so let's try this one out. So let's call it like, let's say 10 to 50. So I got this bunch of values. Okay. All right. So that problem is solved. Okay. Now, so the improvement, let's go to the improvement. I'm going to get this into later, but focus on this one. And this is where, guys, why this is a interview problem. Okay. So remember, like we have, we talk about this umpire technique, right? And then in the implementation, we does the implementation, and then review, we actually try our code or test them out, right? In the evaluate step, right, we ask ourselves, can I do better, right? So in the sense that to improve the memory usage, or and to improve the speed. And you can also, make your code elegant. For example, if your code is messy looking, or like, like a boilerplate kind of thing, and then you can make your code elegant as well. And we already did some, right, a little bit. So how can we improve the speed in this code? So basically, when you want to improve the speed, so you have to basically figure out operations, and then see if you can, bring down the number of operation in a single iteration. So that's where it's gonna basically improve. Okay. So um, in here, so I mean, you can focus on the operations, the mathematical operations, the remainder calculations, right, or modulos, right? Can we bring it down to? Can we bring it down the number of modulos? If so, how? Yes.
Create booleans to represent the cases for divisibility by 3 and 5, and then just plug in the booleans there. So instead
Uh,
of 4, you only have 2.
so what are the two?
It would be like fizz equals integer number. If fizz, if integer number modulo 3 is equal to 0, or if it's not integer number modulo 3, fizz equals true, and then if integer number modulo 5 is equal to 0, fuzz equals true, and then just plug in fizz and buzz into the save state.
Mm, I think it's still we're gonna have the same number, right?
You're checking the divisibility 2 times only instead of 4 times.
I think that's interesting. I Okay, so I need to see the code though, but there's a more obvious way of bringing it down, right? Think about it. It's 58. There are two remainder calculations, right? There is a way to bring it. So that's bring it to 1. So nearly, like, 50% increase of speed. What is it? So what is the minimum number that line 58 returns FizzBuzz? 15, right? So any ideas there along that line? Yeah, right? So why not? So instead of checking both 3 and 5, we can check the divisibility like modulo by 15, right? So instead of two math operations, we have just one there, right? So that's the improvement. So it's kind of like, it's a based on that 58 line 58, it's a reduction of, from 2 to 1, so it's a 50% improvement. Okay, so I'm going to add that, but I'll probably check your code as well, so to see the improvement of your idea. Okay, so this is pretty much they were expecting in the solution from the student. Okay, so here it should be 15. Okay, so then we can get rid of the rest. Okay, so the idea of the lowest what do we call in numerical mathematics, lowest common multiple, right? Yeah, least common multiple. Yeah. Okay, so that's that. Okay, so this is 2 down. Okay, and we can try that one as well. Okay, so I'm gonna write the function that actually use that one. Okay, so let's add the other function, guys. So I'm gonna change this and this function. Okay, yeah, so the other one basically asks you to add the two, like 3 and 5 also. So the number 3, number 1, and number 2, and then make them default to 3 and 5 and 5. So basically here it's going to be so this is going to be the product of number 1 and number 2, right? So times 2, and then it's not always the product though, right? It should be the but let's stick to that one for now for simplicity. So this is going to be number 1.
Also, don't you have to put that? Does modulo have the same? What's it called? Does it occur at the same time as multiplication and division, or should you put number one?
Yeah, it's same. It's same. Yeah, same.
Wait. So if it is the same, then it would do integer number modulo number one, and then multiply that outcome by number two. So you should put number one times number two
In parentheses. Yeah, you're right. Yeah, good point. Yeah, the precedence, right?
Yes,
Yep, you're right. Yep. Yeah, good point actually. Okay. Yeah. So and then yeah. So let's try. Now we can try this one in our in here. So I'm gonna run it for this. So 2, and I'm gonna call this guy. Sorry, this one. Instead of this one. And in here, basically, I think we can get those number 1 and number 2 also as parameters. Okay. And then you can let it default to there as well. So I think I didn't. Yeah. So yeah, we can let it default here as well to 3 and 5. Okay. And I'm gonna call this one. I'm gonna call it like with the default value, and just say 10 sorry 0 to like 40. All right, so I let the function take defaults, and then we get something like this. Okay, all right. Any question? And then this is how we actually set the default. Remember, right, if you have default parameters, then they should be at the end of the list of parameters. Okay, so you cannot put them in the, there's another way to put them. We call them keyword arguments, but it's out of focus of this class, so let's leave it. Okay, so these are just default arguments. Okay, default parameters. So there's another concept called keyword parameters, and then they can be in different places too. Okay, all right. Questions? All right, so let's go to our lesson. So we're gonna, basically we started the for loop, right? So it's over here. Okay, and then so for loop, we kind of learned that for loop give us a way to access items in a container, right? So and then basically it's in plain English also sound like this, right? So for example, if it is if our container is a word like this, so it's a container of characters, right? So content is characters, and we're basically accessing them, right? So right, so we when in while loop, when we learning while loop, we saw that like there's a condition after while, right? So who make that? We make that. So that condition is explicit. Okay, but in for loop, right, it's built into the for loop header, right? So it's actually implicit. So basically, so that's a big difference. That's the big difference between the while loop and for loop, right? For a while loop, right, engineer or the coder coming up with the loop condition. So we write it explicitly. In for loop, right, the 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 syntax contains the condition itself, right? So it's actually implicit. But both while and for checks a condition at every iteration. Okay, so for example over here, for checks, right? So for loop checks, and then once it start, we actually print the character, right? It goes back to line number 2 again, and then check what is the next character in that word, right, in that container, right? And also at the same time, it's also check, am I at the end, right? If it is not, it's actually go down and then print that character, and then goes back again to check. Okay, so that means, like, if you take two equivalent while loop and then the for loop, right, both has equal amount of conditional checks in there. Okay, so you can assume that, okay, it should run equally fast, both loops, right? But some say there's a small um, increase of speed in for loops, probably because it's implicit the condition, right? Maybe because of that. Okay, all right. So now the problem is, okay, so we can actually, if we have a container and then if we want to do something or access it content inside, we can loop over it, right? But let's say we want to do something certain amount of time, certain number of times, right? So how can we do that? So in here, well, we have to do something with characters in the word, right? So in this line number 3, simply we are printing it, right? But imagine we, like, think about that, push up example, right? Do push up for 50 times. That's a number there, right? So how can we do something for a certain amount of numbers using a for loop, right? And that's actually a pretty common application, right? Like, for example, a push up example, or track example, right? Basically, ranges solve that problem. So Python designers saw this is really a common application of um, you know running a single task for a certain range of numbers or for a certain number of times. It's pretty common in in, in computing. So they decided, okay, so we're gonna facilitate container of numbers using a different data type. So they created range as a fundamental data type in Python. Okay, all right. So that's a different type. So today is the first time we are encountering this data type in this class. So it's actually provide a numeric range, okay, based on a pattern, and so a variety of ways to create ranges. Okay, so as a data type, it's a immutable data type. It's an immutable sequence, right? Like strings. Okay, ranges are immutable sequences. All right. Okay, let's get our break, guys. Okay, so be here at 12:10. So, guys, next Tuesday, let's do the workshop. Okay, so surely can you be here 9 at 9? Oh, not 9, at 10. At 10, and then I'll also ask Syria as well. So, guys, we'll be doing a workshop for, like, remember we did one for programming assignments. So you're gonna do a one of those on next Tuesday, okay? And we're gonna come to you guys and ask you guys to open in, and we're gonna help around. Okay. Okay, so let's watch our video today, which is this one, the for loop one. Okay. So this one they're gonna use. They are using JavaScript. So just take a note on that as the language. I just published it. I think this should be. Let me see. Um, yeah, I'm gonna change the due date actually. I forgot. Okay, so preview. All right, so basically Python created ranges to support numeric range values. Okay, so because it's actually really common scenarios in which we need a numeric sequence of numbers to do things. Like, for example, counting up and down. Like, for example, this Artemis one, right, was count down problem, right? And also do a certain number of tasks, right, repeatedly, right? So so let's generate our range over here, the first one. Okay, so I'm going to create a range. That's a range equals range up to 5. Okay, all right. And then we're going to print it. Okay, I'm gonna add this check type as well. We should be getting range. Okay, so and you can see that it's a range type. Okay, and well, this is not that helping, right? Well, we already see it's a range of 5, so we'll get the same, right? So the reason is basically when we ask Python to create a range, it doesn't actually generate the content of it. It's actually create a formula and then keep that formula in the memory. Okay, that formula is actually coming from it's an arithmetic sequence actually, right? So use that sequence formula and then keep the formula in memory, not the values. And then only when we demand the values, it's actually use the formula and then spit them out. Okay, and that's why ranges are actually efficient when you want to, let's say, loop over like over certain number of times. You can always create a list of that amount of length, right? And then do it, but it's actually efficient because again, when we demand that number, it's actually generates. So it's only keep that formula in memory. Okay, so then how do we see these values? So I mean, this is not helping, right? We want to see the values inside the range, right? And then these values are actually 0, 1, 2, 3, 4, right? Ranges are exclusive. So the n parameter is actually not included. So we can basically print, actually put the range inside a list. Okay, so list, I'm going to use a list function. Um, so basically we're going to generate a list out of this range. So notice when you create a list, you can actually pass another sequence, including another list to list function, and actually generate a list of items out of that items in that sequence, right? So right now the sequence is a range, so it's going to give us those numbers. Okay, and you can see that it's a list of the content of the range. Okay, 0 to 4. Okay, so if we try to create another range, let's say I'm going to print range, I would say 1 to 10 and in steps of 1. Okay, so basically this is the most versatile call of the range. So we call this is the start, end, and the step parameter. Okay, so default step parameter is actually 1 always, so it makes sense, right? Stepping by 1 when you increment the sequence. And also default default start parameter is also 0. So right here it's 0, that's why we saw it's 0 right here, right? So that's the default. If it is missing, then the default start parameter is actually um, the 0. Okay, all right, and then the default step parameter right here again, it's actually 1, so it's stepping by 1. Okay, so let's print this one. You can see that, oh sorry, I need to pass this into a list to see the values. Okay, and you can see that we got the numbers from 1 to 9, right? So ranges, the n parameter is exclusive, that means we will not include that. So basically what we will get it the maximum possible number which is less than the n parameter. Okay, based on the step value. Okay, so for example, if I print this one, okay, so if I put 2 over here, this we are stepping by 2 now. Okay, so we'll get up to 9. Okay, so 1, 3, 5, 7, 9. We cannot go to the next one because next one is lower. All right. So likewise, okay. Oops, it's right here. And you can see that step parameter can be negative as well. So that means basically we are now kind of counting down situation. So the start parameter has to be more than the end parameter, and then the negative the step can be negative value. Okay, so let's print this one as well. Okay, you can see that we get the these values. Okay, and then can this also be true, right? Like, if I do this, is this an error? Because, well, logically it should be an error, right? Because you cannot count down positively from a bigger value to a smaller value, right? So um, because the stepping value is positive, so it should count up, right? But if you run this one, what we will get it empty list. So that means Python ranges, what we say is Python ranges are forgiving. So it doesn't, there are so occasions it actually gives you an error, but mostly if we can generate the range, it actually gives you empty range. So nothing in there. So basically you get an empty list in this case. Okay. All right. So we say basically Python ranges are uh, forgiving, and I think same for the splitting as well. Okay. So sorry, not splitting, slicing, string slicing or sequence slicing. All right. So let's continue. You can do the last assignment here. Oh, I already did that, didn't I? So let's go to next level. Okay, so this one, positive integers, batch lower and batch upper are read from input representing the batch numbers assigned to a collection of experimental data. With batch lower less than batch upper, complete the for loop to iterate through the increasing sequence of all integers between batch lower and batch upper, both exclusive. Okay, so we need to actually create the range over here. So both exclusive. So range, and this is the usual pattern when we loop values over range. We pick the you usually pick a single letter. Usually it's I, because this is a number, right? So that's why we take I, but it can be any expressive name as well. Okay, so what should be the values, guys, over here? Batch lower less than, okay, so batch lower, but both exclusive, right? So that means, oops, yeah, so batch lower plus 1, right? And batch upper, that should be enough, right? You can leave the default stepping value to 1, so it's default one. So let's test this one out. Oh, we got it wrong. Let's see what it is. Oh, it's a syntax error. Why? Let me see. Oh yeah, yeah. All right. So in range. Thanks. There you go. Okay. All right. So to like further show you an example of ranges in action, so the kind of to indicate the utility of actions. Let's say I want to start from a number and then add, so print the numbers in increment of 3, right? So let's say up to like 10 times. So I'm gonna say I'm gonna start with the for loop, right? So for I in range, and the range is from, let's say, 0 to 10. Okay. And then my number is, initial one is, let's say, is 0. I want to increment this number by 3 10 times. Okay. So print, right, number. So what should be the, how do we increment? How do we increment? What's the operation? Plus equal, right? 3. Okay. All right. I think yeah, this is fine. I can, well, I'm gonna take it out and then print the number. So like this, and then print number. Okay. So I get values like this. Okay. So and then this just show you application of a like range based for loop. Okay. Now we already encountered, okay, if there's a sequence, we can access elements using a for loop, right? Like right here, right? Okay, so we were accessing each character element at a time, right? Or item at a time. Same here as well, right? Okay, so in this case, it was a list. Okay, it's a list of words, right? So I have a question now. Is there another way of, so this is basically accessing element by element or item by item of a sequence. Okay. Is there any other way of accessing a sequence using a for loop? I mean, my problem, my question probably vague. Like, so this is one way of accessing. Definitely, we can say that, right? Accessing element, and it's actually element by element, right? For example, it's a list of words. So we said for words in words, print them, right? So we are simply going word by word, so element by element, right? How can, is there any other way to access these values? And then what is that? And then you can see that if you take the English of it, like in line number 5, right? For word in word. So basically we went by, went through by one element at a time, right? We went to the first element, next likewise, right? So it's element by element. But what is the way we have the order in the words, right? It's ordered, right? Yes. Yeah, using the index, right? So that means you can also access them by index, right? So if we are to do so, then how do we do that? Using a for loop still. We now have to, yeah, so index by index is the idea actually. That's what, but how do we actually implement it?
Oh, use a range.
Yeah, we have to use a range, right? Because remember, ranges provide a sequence of integers, right? And we can actually craft, you can actually get that range, like set of integers which happen to be indexes now through a range, and then create a range based for loop to access the container in that way, right? So let's do that as well. Okay, so I'm going to copy this um, code. All right, now instead of, so this we call element by element iteration of a container, and then here is the index by index iteration. So for I, so because it's a number now in range, we need a range now. So I would say there are utilities to either case depending on what we actually repeat. Okay, and then basically, so well, it's start is 0, right? So we can leave the 0 there. The take the default value of range is 0, so we can leave it there. What should be the end? Yeah, length of words, right? So basically, because it's actually ranges are exclusive, so and then the step value is 1, so it's 1 less than the length. That's what we want, right? And then what should come over here? Words and index I, right? So this should be, sorry, words index I. We are accessing the ith index. Okay, and we will get the same like above in this way as well. But in this particular setup, this is much inefficient than compared to the previous one. Why? Because we are actually creating another data structure, right? Even though it's sitting in the memory, right? So it's probably runs slower, but depend on, like, again, so we'll still have to do a measurement on that actually, because in Python they say ranges are actually fast because again it doesn't store these values in memory. It's only keep the formula in memory, and only when we demand them it's actually spit out these values. Okay, all right. So so we're gonna actually finish this module next Tuesday, guys. Okay, and we will start the functions 2 module Tuesday as well. So there's a I think the rest of the sections are just like practices and things. Okay, so you can actually go fast on those. Okay, so with that, um, so let me quickly go over the two few things you need to submit. Okay, the first one is this one, graded discussion. Um, so minimum numbers input until a sentinel, right? Okay, so the sentinel here is actually -1. Okay, so that's the sentinel, and until you see the sentinel, you have to actually ask for an input, and then figure out whether it's minimum or not. Okay, and in this is a rare occasion in which you will have to actually call input function in your function. Okay, so but yeah, usually it is less common. So if you use a function, okay, all right, and then basically do it in here, and post your Python sandbox code, and then once you post yours, and you will see, and then just reply to one other student, okay, to get the full marks. Right, so okay, so that's the discussion assignment. In this high book, you guys have a really good match for this one, right? So we have like, we actually in week 2 in binary numbers we learn the technique, right? the reverse, what do we call the repeated division, right? Yeah, that's the algorithm. So basically you are going to implement that algorithm here in code, and then basically you're going to create a string out of it, and then you are not going to reverse it, just the um, you're going to basically get the reverse view of the number, binary number result you're going to get. Okay, so yeah, take a look at the template code, just one input function call in the main, right? And then you should take that input as a parameter to your function. Okay, and then the assignment. So this one is a kind of interesting problem. So um, Jacob problem. Okay, so this one so you have to calculate the population based on number of generations. So basically you find the new, each generation you have to calculate the number of birth and calculate the number of deaths, and then calculate uh, the 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 sum, right? And then you add it to the population, and run it for the number of generations, right? So it's a for loop problem. Okay, but make sure you have to you do both the death, you account both death and the the births. Okay, all right, and then there's instructions, and then please follow them. It's a code check problem, so these are the criteria that you have to run. In this case, you simply call your function 4 times with these parameters. Okay, so that's all you have to do. Okay, any question on this one? We only have 3 and 3 TAs and 3 students. All right, okay, that's about the problem, guys. Okay, so let's open the problem today, which is this one. I just published it. All right, so we're going to estimate the value of pi. It's a for loop problem or loop problem. Okay, using this number sequence. Okay, is the is programming language keep a constant value for Python, or it's generate? Like, does it store the value of pi, or it's actually generate it? Probably storing, right? Like a, yeah, like a math constant, yeah, like a constant, right? So it doesn't generate, it's probably uses stored value, right? Yeah. So basically what I mean, we use one of the one, like, kind of this kind of algorithm to generate the value of pi first, and then probably we can use it. Okay. So you'll have to this one you'll have to do a really good understanding step, guys. Okay, so basically we basically need to figure out what is the repeating pattern which we're going to use in a loop, right? So to figure that out, I would say, like, start write these terms from starting from term 1, term 2, like, like, let's say number of terms 1, 2, 3, like up to like 5 or 6, and then write them down, and then see where the pattern is coming, right? And you can see that all the numerators are common, right? 4, right? So that means constant, it's not changing. But check the denominator, right? It's changing, right? Based on the term's number, right? So if you can find out the relationship between the numbers in the denominator and to the term number, and that's what's going to be the repeating pattern. And also you can see that the sign also alternating, right? So negative, positive, negative, positive. So it's also alternating. Okay, and you'll have to implement that as well.